means that the direction of acceleration would be down. And so as soon as I release it, the thing does fall. But there's nothing to move it left or right. There would need to be a force in order for it to go that way, one of those two ways, when I release it.
Would that force be, no, I've heard it before, by torque or, yeah, torque.
Torque. When I release it,
Like that's the resulting, that's why it goes.
no, it's not. Torque would be an outside influence, potentially.
Okay.
No, it's weight. Yes, you could work torque into it if you had to, but that comes up later. So what this was hopefully trying to show you is that when I release it, the only force acting on it is weight, so it should go in a plane. It should go basically straight down, except it should go in a straight line, except for the fact that there's a force downward, so it does curve down. Which means that when I release it, since it wants to go that way, that is the direction of the velocity. The direction it's moving in is the direction of velocity, and in the absence of outside forces, the velocity will stay constant.
So had you released it in front of you
Oh, here?
here, then it would have gone that way.
Yes.
Huh.
True story.
So it goes, so wording that would be the object in motion will always want, the direction of which it wants to go is where it will end up going. And then it'll hit the ground.
When you release it, yeah, it'll go, it then becomes a projectile motion problem. I think it's a 251 master set problem where I do a David and Goliath thing. And so got him swirling it on a rope, he releases it, so it goes from a circular motion problem into a projectile motion problem. All right, questions up to here? All right, so it is moving, so this is a right angle, because that's the path it's going in, is tangent to the path. And we've established this angle is phi. All right, so let's break up the vector. So I have this vector v at this angle phi, and I want to break it up into horizontal and vertical components because that's the way I set up my axes.
Oh, so you just do v sine phi
Is which one?
is the vertical one. And then v cosine phi.
All right. All right, so A is equal to the final velocity, so that's the one over here, so that is going to be v cosine phi I hat minus, because it has a downward component, v sine phi j hat, that's my final velocity, minus my initial velocity, which is v cosine phi I hat plus v sine phi j hat divided by time. Into what does this simplify?
Why are you multiplying? Oh, okay, never mind. It's the same thing, so it's twice.
Yeah, well, I mean, it's this minus that, so this gets broken up also.
But it being the same, being in the same diameters, then, I mean.
Same angle, same
angle,
magnitude.
okay, so
Yeah.
it's the same thing.
The big difference is that this is a negative, so minus the j hat component, and this is plus the j hat component.
Why is that again?
Because the final velocity is going down like that, I define j hat to be up. Final velocity is down like that, so there's a downward j hat component, and the initial is up.
Okay.
If I had a minus b minus a plus b, what does that reduce to?
Zero.
No. That would be interesting, that would, be basically
Negative.
saying somebody travels in a circle at a constant speed, that the acceleration is zero.
Be negative 2v.
Distribute the minus sign and then add, you get a minus a, that cancels out, negative b minus b, negative 2b. So this over here becomes negative 2v sine phi j hat over time. And that's the form, no, that's not the form, we're not done. I'm gonna rewrite this slightly, I'm gonna put negative j hat up front, because that's the directional piece. So the acceleration will be down, 2v sine phi over t. Now, we're gonna simplify this again. Well, first off, it's traveling at a constant speed for a certain amount of time. For time t, it's traveling at a constant speed. So the question I have to ask you is, how far does it travel from here to here? If it's traveling at some speed v for a certain amount of time t,
We need t.
say it again?
We need t. We need time.
If I told you the time, what would you do?
I'd probably put it into a. Wait,
Sure. Anyone want to narrow that down?
wait, you said acceleration is constant?
I said the scalar acceleration is zero, because the speed is constant.
So acceleration, the vector would be.
Well, that's what we're trying to find,
Oh.
the vector one. If you're driving 50 miles per hour for 2 hours, how far do you go? 50 miles per hour for 2 hours.
100 miles
How do you get that?
times 50 by 2.
Yeah, all right. So if you're going at some speed v for some time t, how far do you go?
V times t.
Yeah. So this distance here, from here to here, is just v times t. Ah, now it's all clear, I'm sure.
And does not, if you're going, and that's even if it's a curve, that's even if it's straight, that's even if it's angular.
If speed is constant, speed times time. The classic middle school distance equals rate times time. All right, so I now have this relationship here. I have VT, and I've got this angle here, and it's a circle, so there's some radius r. What's the relationship between this angle r and that arc length?
No, there's.
I'm not quite sure what would be parallel there. I mean, we're dealing with arc length. So the whole thing, this radius and that angle.
What was it? S equals. S is arc length equals,
tag team it. So I wanna beat him to the punch. Ruin Ibrahim's day, just shout out the answer right before he says it.
You know exactly, or,
Alright, put it away.
okay.
What do you know about radians?
Radians are a unit of measure instead of degrees.
Alright, so a unit of angle, okay. How many radians are there in a circle?
2.
If you're stopping there, no.
2 radians.
No. It turns out radians are unitless, so,
2 pi radians.
yeah, I'm not quite sure what I said triggered the pi, but, yeah, 2 pi.
I heard a whispering echo in the background that I heard. Guardian angel did.
Alright, so angle and arc length. So if the angle is all the way around the circle, 2 pi. So if we're doing an entire circle, we're dealing with the circumferences. The arc length is the circumference. What is the circumference of a circle?
2 pi r.
Suppose I'm doing 180 degrees, so a semicircle.
Pi long. Oh, the angle, just one, or just pi.
So angle is pi and the arc length. Is there some sort of pattern? If I gave you just some generic angle here, theta, what would the arc length be?
Theta r.
So the arc length is just r theta or theta r, depends upon your mood.
See, that was
Were you trying to pull up memories from this class or trying to pull up memories from math? Or just general?
both. We went over that at the very beginning of class.
Okay.
But on a different note.
All right. So if the arc length is r times theta, that means that well, the radius is constant, otherwise it's not a circle. So if I do a change in the arc length, I got a change in the angle. And so if it's moving along a certain arc length over time, well, what is this? This is a distance divided by time. What is this?
That's, velocity. No, hold on.
Distance.
Distance over time.
Nobody just said it. So speed is equal to r times this right here. Which I'm just gonna leave as the angle over time. Well, our angle in this case is 2 phi over time. I was about to get into angular speed, but that's later.
So, the velocity is constant, right?
Speed is constant.
Speed is constant.
If the velocity were constant,
It'll
acceleration
be
is
in
0.
one direction.
Correct.
Oh, okay, so that's our speed.
Yes.
And is there any way we could like calculate the change in like direction? So
Well, that's sort of what we're doing right now.
Oh,
We're trying to figure out what is the acceleration for something which is only changing direction, not changing speed. All right. Now we have one more piece of the puzzle. If you have your calculator, I would recommend that you pull it out and put it into radian mode. So if the angle is 0.01, what's the sign of 0.01 in radians? If 0.01 is in radians.
0.00999983333417.
That's pretty darn close to 0.01.
Sure is.
How about the sign of 0.00? 1.
That's pretty darn close to 0.001.
Oh, what are the odds? How about the sine of 0.1? Shouldn't be getting further off at this point.
That's pretty darn close to 0.1.
What is this one?
This one's 0.099833416.
All right, so we're still pretty darn close there. Let's see how far we can take this. The sine of 0.2.
0.19866.
Notice that when the angle is small, you're a lot closer, but the larger you get, it starts to deviate, but still it hasn't deviated too far at this point. So I introduced to you, probably introduced to you, the small angle approximation. Flashback to the fact that all of this was done pre-computers, or the computer at that point was a person. So they were trying to find sort of some shortcuts. The small angle approximation is that if the angle is much less than 1, so you got the double less than symbol means much less than. If you need to quantify it more, typically you consider it under 10%. Then theta is approximately equal to the sine of theta, which is approximately equal to the tangent of theta. And this is in radians. 1 radian is 50 something degrees.
Can you say that one more time?
So if the angle is small,
Yes.
that the angle is approximately equal to the sine of the angle, which is approximately equal to the tangent of the angle, assuming you're dealing with radians. Now,
Where did tangent come in?
it just happens to work with tangent. We don't need the tangent piece, but that's a small angle approximation.
Okay.
In terms of deviating, tangent deviates first. I mean, you can start, tangent of 0.2 is going to be farther off. So, let's talk about units for a second here. Going back to S equals R theta. S is a length. So what would be the standard unit for length?
Meters.
R is a length, it's a radius. What's the standard unit?
Meters.
So theta would be the arc length divided by the radius, and if that's in meters and that's in meters, units would cancel out and there are no units here.
Meaning it's radians.
So radians is a unit that you generally put in for communication purposes. And I might have done this bit already, but we'll do it again. If I said that the angle was 30, if I don't put units on there, it should be assumed radians. But if I just say the angle is 30, you would wonder, did I mean radians or did I just forget to say degrees? So you say radians just so it's clear. So if it's 30 radians, it does technically mean the same thing as the angle is 30, but it's clear I didn't forget to say degrees.
So 30 radians and 30 degrees is the same?
No, they are not the same. That's why
Right.
confusion can reign. And then on that note, sure, could have been one of the other classes. I had a student just tack radians on to all of his answers. Why not?
That
Okay.
might be different.
So, given our problem right here, I want to find the acceleration at this point, smack dab in the middle. So what I'm going to do is I'm going to let phi become smaller and smaller. As phi becomes smaller and smaller, sine of phi gets closer and closer to phi itself. So this, I think it's only the second or third time I've done that. Negative j hat 2v, so this one, let phi approach 0. Phi is not equal to 0, it's just getting closer and closer to 0. So I'm basically taking my wedge there and I'm making it smaller and smaller. For the math purists, the limit as phi goes to 0. This becomes approximately 2v phi over t. Well, 2 phi over t, well, we can just solve for that. 2 phi divided by the time is just, well, let's bring r over, it's just v over r. So I'm gonna take my 2 phi and substitute it in my v over r. So what I'm left with is negative j hat v times v over r, or negative j hat v squared over r. This is the formula. We'll amend it slightly. Actually, let's go ahead and amend it first, and then I'll do the grand announcement. This negative j hat means that when I am here, because if I go to get closer and closer to 0, so we're talking more and more of the acceleration at this point right here. That acceleration is in the negative j hat direction, which is down. Well, I can set up my coordinate axes any way I want to, so if I want to figure out the acceleration there, I can just also go through the exact same process. It's always going to point towards the center. So in general, negative r hat v squared over r, and that is the formula for centripetal acceleration.
What does the R stand for again?
Which one? The r hat?
The negative R.
All right. So with unit vectors, we've dealt with I hat and j hat. The direction of I hat is whatever direction we want it to be, and j hat's perpendicular, or beside j hat and I hat's perpendicular. R hat is a little bit different in the fact that R hat, it's a unit vector, thus the hat.